In this video, I'm going to explain to you how hexadecimal works. If you are here because you want to know how to convert to and from hexadecimal, I have other videos on that. Let me take you back to when you were at primary school. When you were first learning how to count, and ever since then, you probably count in a number system called base 10, deanery. Some people pronounce it deanery. It really doesn't matter, but we count in groups of 10. The reason why we count in groups of 10 is because most of us are born with 10 digits. So when we were in the caves and we wanted 30 lion skins or whatever, I don't, it was easy to indicate, so we just counted in groups of 10s. So let me remind you how that actually works, because that is really helpful for other number-based systems as well, because they're all the same. So as I said, we count in groups of 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 10 units, including 0. When we get to 10, there is absolutely no way to represent 10 in one single character. What we have to do is we have to go into the next column. So what we are really saying here, yes, all of our lives, we've known 10 to be like that. But actually, mathematically, what we are saying is we've got one lot of 10, one group of 10, and nothing else. So for 11, we've got one group of 10 and a 1. 10 plus 1 is 11. Next, we've got a group of 10 and a 2. 10 and a 2 is 12. And that's really how our number-based system works. When we get to 3, 4, what? When we get to 3, 4, 5, 6, 7, 8, 9. So when that one's filled up, we've got one lot of 10 and 9 units, 19. So what do? We can't go any further with this 9, so we need to go into the next column with that 1. But we've already got a 1 there, so it becomes 2, 0. Yeah, so we've got a 1 there. We get to another group of 10. Over it goes. 2 groups of 10 now, and nothing else. Exactly the same in hexadecimal and any other number system. In hexadecimal, we count in groups of 16. There are other number systems as well that count in groups of 8s and whatevers. This one's just really useful for computer science because of the size of a byte. But we're not going to worry about that. Let's just understand how this works. So our 1s, our units, 0, 1. We've got a bit of a problem because when we get to 9, we can't do that. We can't represent 10 like that because that uses 2 characters. So when we get to 9, we've got a major problem. Not 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to represent 10, but we can't do 1, 0 because that's saying that we've got one lot of 16. We're counting in groups of 16s now. This column is 16s. We've got one group of 16 and nothing else. Well, what's 16 and nothing? 16. That number's number 16. So that's not good. And we can't do what I just did and put it there because we need to represent it in one character. Now, you could just invent a squiggle to represent 10 and 11 and so on, and people have. But we're not doing it that way because if we use letters, it's easier for us to identify. We don't have to memorize some kind of hieroglyphics, but also we can see the sequence. So we capitalize that. So A is 10. All right. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. To represent 10, we're just going to arbitrarily, we could have used squiggles. We could have used blotches of colour. I don't know. We could have used anything. Somebody decided we're going to use a letter. Fine. A. But that's quite useful because we know, most of us, that B comes after A. So B would be 11. Let me just align that over there so it's so AB, so to represent 12. Now remember, we need to go to 15 because including 0, we're counting groups of 16s. 16's that column, so this column is one below, just like 9 is one below the 10s column. So we need to count up to 15 in digits and letters as well. A, B, C, D, E, F. Look at that. F equals 15. Remember that, and you will go far with hexadecimal. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to use a single character. So we just use letters. A, and then B, C, D, E, F. Stops at F. F is 15. Magnificent. So how do we represent 16? Well, there's two ways to think about this. We've run out of units because we've only gone up to 15. So therefore we need to go into the next column. All right. Another way of looking at it is these are 16s. So we are saying we've got one group of 16 and nothing else, which is 16. Just like here, we said we had one group of 10 and nothing else, which is 10. So anything in this column is worth 16. Anything in this column is worth just the unit value. All right. So I write 1, 1. You notice I'm not calling it 11. I'm saying 1, 1. What's 1, 1? Well, you can probably work it out by looking over here. But 16, we've got one lot of 16. So there's our 16. And then we've got a 1. 16 and a 1 is 17. And hey, look at that. That follows the sequence. 1, 2. All right. We've got a 16 and a 2. 16, 17, 18. A 3, 1, 3. So we've got a 16 and a 3, 16, 17, 18, 19. 1, 4. So working it out, we've got 16, 17, 18, 19, 20. And so on, and so on. What happens though when we get to this situation here, where we've got 1, 9. All right. What is 1, 9? Well, it's 16 plus a 9. What do we do? Do we go into the next column? Say it out loud. Say it out loud. Do you think we go into the next column? Do you think we do that to represent 26? Because we've got to 9, yeah? So we've run out and we go into the next column. But we haven't run out. And if we go to the next column, they're 16s, they're a group of 16s. What's 2 times 16? It's 32. So what we're saying is we've got 32. That's the number 32. Well, that's not right, is it? So what we want is we want to represent 1, 9. So we want the number after 9. What's the number after 9 in hexadecimal? It's A. A is a 10. So 1, 9, 1A. Why is it 1A? Oh, come on, let me just sort this out. Why is it, come on, why is it 1A? We've got a 16 and a 10. A is 10. These are 16s. 16 and a 10. What is 16 and a 10? It's 26. Well, what do we do now? We need 16 and an 11. B. And so on. You don't even need to work it out. And the number that we go, why is it doing that? I thought you could do that. A, B, C, D, E, F. All right, now we've got a problem though. 31. What do we do here? How do we represent 32? We've run out of units, so we need to go into the next column. There's a 1 there, so we just increment it to 2. Another way of looking at it is we need to represent 32. How do we represent 32? Well, 32 is 2 lots of 16s and nothing else. How do we represent 33? Well, it's 2 lots of 16s, 32, and a 1, 33. How do we represent 34? 2 lots of 16s, 32, 3, 4, and a 2. And then that just keeps going all the way up to F. And then it will go up to 3, 0. Hope you found that useful. If not, you can rewind things on YouTube or just go somewhere else. I hope you do manage to work it out, because when you do, when it clicks, it's fine, but just getting there is a bit tough. So don't worry if you didn't get it first time. Stick with it, and that's about it. In a bit.